So we're going to look at 8.3, number 17 and 45. So on 8.3, wants us to sketch the graph by eliminating the parameter, and the parameter in this case is theta. But it's pretty convenient that it's cosine theta. And so I could solve for cosine theta and divide by 2 on each side here. I have x over 2 equals cosine theta. So this x over 2 can replace the cosine theta there, and y equals 3 over 2 times cosine theta. Oh, not cosine theta, it's times x. Times x. There we go, because we eliminated that parameter. And so it's easy to just graph that, except we have to consider this. Our original function had x equals 2 cosine theta, and so we have to think about what would that produce in terms of x. And the biggest cosine theta is going to produce is a 1, and 2 times 1 is 2. And the smallest cosine theta is going to produce is a -1, and 2 times -1 is -2. So that's going to be our limitation there. And same thing for the y. The biggest it's going to produce is going to be, because the biggest cosine can produce is a 1, so that's 3. And the smallest is a -3. And that's it. So now we can go ahead and graph this. And I think we probably see what's going to happen. I mean, if we just graph it, we know that let's change colors for the graph. We know that's going to have the intercept of 0 because it's y equals 3/2 x plus 0. Then the slope is 3/2, so up 3 over 2, or down 3 to the right 2. And that is our graph right there, and it ends at those points, by the way. So that's number 17. Let's go back and do, or not go back, let's go forward and do number 45. 45 says, construct parametric equations for the circle with the given attributes. So we have center at 0, 0, and our radius is 1. So that's going to be x squared plus y squared equals 1 squared. And, I mean, if we were just to talk about doing a circle, I mean, just doing parametric equations, we could say that, you know, like r squared equals 1 squared, or r equals 1, and there's no theta, so that's your equation of a circle. But in this case, they want us to do parametric equations. So if we think about in the parametric equations, y equals r sine theta, and x equals r cosine theta. So y would be 1 times sine theta, and x would be 1 times cosine theta. It still have the property if we were to do 1 times cosine theta squared plus 1 times sine theta squared. That just gives us 1. So our equations are simply, this is a little anticlimactic, but it's x equals cosine theta and y equals sine theta. That's what we're after. So hope that helps.